Hi and welcome back to my channel. So in the last video I talked about the definition of derivatives. To summarize it again, we got to know that derivative of a function is the rate of change of the value of the function with respect to the independent variable. Also, we know that not all real life relationships are linear. So we can't really use standard way of finding a slope of the line to find the rate of change. So for example, we may want to know the instantaneous acceleration of a vehicle when the speed is constantly changing with time. So we just calculate the rate of change of speed with respect to time. So that is a real life example of derivative, and mathematically it can be written as acceleration of the vehicle as change in speed with change in time. So I'll just write it as ds by dt. So ds is the change in speed with the corresponding change in time. So this is why derivatives are very important in real life. So let's talk about some of the common notations used for derivative of a function. So if I have a function y equals f of x, and derivative can be shown as f dash x or d by dx of f of x, or simply dy by dx, or dy by dx at x equals any point, let's say a. Also d of f of x is also called the derivative of the function. So today we are going to solve some problems based on the derivative, and in the last video we got to know how to use limits to find the derivative, or simply the slope of the tangent at that point on the curve. So we know that to find the derivative of function we write as, to find derivative of any function f at any point a, the derivative as given as t is given as limit h approaches 0 function of a plus h minus f of a by h. So now let's solve a question based on this concept. So we have a question, we need to find the derivative of x at a point 2, x equals 2, when function is given as f of x is given as 3x. Now we can use the previous formula also by making a graph of this function. It'll be a little bit clear. So if I make a graph of this function like this, so we know, let's say it's 0 here, and then 1, then 2, and then 3. It's an exponential function. It is increasing like this. So when x is equal to 2, we have the value of the function is 6. So it'll be around, let's say it'll be around here. And when it's 1, so it'll be around here. Sorry, when 1, so it'll be around, this is 3. So we can see when x equals 1, the value of the function is 3, and when x equals 2, the value of the function is 6. And at the point 2, we need to find the derivative. That means we have to find the slope of the tangent to the curve at this point, right? So for that we need two values on the line, so which is a little bit difficult to find the the slope of the tangent. Rather, we can just use the formula which we have using the limits. So we have limit the derivative is given as limit h approaches 0 f of a plus h minus f of a by h. So here we don't know, h is unknown to us, so we simply substitute a as 2, and then we find the derivative of the function. So we can write this as limit h approaches 0 f of 2 plus h minus function of 2 by h. So function of 2 plus h will give us 3 times 2 plus h, because function of x is 3x. So we simply substitute 2 plus h in place of x and 2 in place of x. So we have minus 3 times 2 by h. So we are left with 6h plus h minus 6. So sorry, we have 6 plus 3h minus 6 by h. So 6 and 6 will get cancelled, so we're left with 3h by h. Applying the limits, h approaches 0, we know h and h, so we are left with 3. So the limit at point 2 is 3. The limit of the function, the derivative of the function is 3 at the point x equals 2. So now moving on to the next question, we need to find the derivative of the function f of x equals 2x squared plus 3x minus 5 at x equals minus 1. Also prove that f dash 0 plus 3f dash minus 1 equals 0. So here we have function of x is given as 2x squared plus 3x minus 5. So let's solve this function. At first we need to find the derivative at x equals minus 1. So we write it as f dash minus 1. This is also a derivative, notation of a derivative. So limit h approaches 0, function of minus 1 plus h minus function of minus 1 by h. So we simply substitute in terms of x, and we get the function value of the function. So we write it as limit, we kind of expand it. So we have 2 minus 1 plus h square plus 3 minus 1 plus h minus 5 minus 2 minus 1 square minus 3 times minus 1 and plus 5 whole divided by h. So it boils down to limit h approaches 0, 2h square minus h by h. So applying the limits, first taking out h as common, you're left with the limit h approaches 0, 2h minus 1. so which the limit the derivative comes out to be -1, f dash -1. So now we need to find the derivative at 0. So f dash 0 will be equal to limit h approaches 0, then simply substituting in terms of x, we have 0 plus h, f dash 0 by h. So we simply write the function here. We have 2 times 0 plus h square 0 plus h minus 5 minus 2 0 square minus 3 0 plus 5 whole divided by h. So it boils down to, again, we get 2h, limit h approaches 0, 2h plus 3, so which comes out to be equal to 3. So we have to prove that f dash 0 plus 3 times f dash minus 1 is equal to 0. So we got f dash minus 1 as -1 and f dash 0 as 3. So clearly f dash 0 plus 3 times f dash minus 1 is equal to 0, because this is 3 and this is -3. So this concludes this video, and if you like, you can watch the previous video where I discussed the basics of derivatives. Do check that out, and I will share the link in the description. Thank you for watching.